in terms of my background, apologies if you can't read it, I think the font is reasonably big. So I started life as a developer a long time ago, worked for Reuters in London, real-time systems, relational databases, fabulous company to work for, 6 weeks annual leave, 9-day fortnight, so, every 2 weeks you get 3 days off, brilliant. Then slowly over time they clawed everything back, of course, but I was very privileged to work with some of the smartest people I've ever known in my career, right at the beginning of my life. Went back to academia to do research. City University in London, worked on database performance benchmarking, and that was the late 80s, early 90s, and of course, in those days, the big thing was object-oriented databases. That's what everybody was talking about. That's going to be the next big thing. Relational is dying. It's had its day. And 10 years later, it was XML technology. That was going to be the big thing. Today, of course, it's NoSQL. That's the next big thing. Got out of academia, went back, worked for Logic as a consultant for a while, joined a couple of vendors, started life with Computer Associates as a technical architect. Worked for Informix. Not sure if any of you have heard of the product. Quite a small relational vendor. Sybase was another one. And IBM acquired it. So I ended up working for IBM, not through choice, but they bought the company I worked for. But I can't complain. Had a great time at IBM working in developer relations. I got to see the world. I met my wife. Okay, so she's from China, so it was fabulous. I'm appreciative of that. And then last couple of years, I've done some stuff in the big data space. So started with Hortonworks, and subsequently went on with DataStax. They do Cassandra, enterprise version, and independent consultant. And now I work for GridGain as a consultant, and it's great because they pay me money to talk about open source. So, what more could you ask? And I get to see the world, so more of it, the bits that I haven't seen already. Okay, so broad industry experience, load of technologies, programming languages, C++ and Java, I guess, are the two main ones that I've worked with, but I've dabbled in some other stuff over the years. Eclipse, did a lot of stuff on that, which IBM, of course, donated to the open source community. Database systems, naturally, that's my background. So lots of client-facing roles, developers, senior executives, journalists, publications and presentations. Here are some of them. So 10 books. And these make wonderful gifts for family, friends, Christmas, any time of year. If you've got, you'll notice they're kind of dated. It's old stuff. I gave up writing ages ago. It's too much trouble. It takes 2 years to publish a book. By that time, the world's moved on. You're already out of date. Technology is, really gone ahead. So I get a royalty check for about $25 every 6 months, so I have to keep the day job. So many years ago, I was actually involved in running the London JSIG, as it was called, Java Special Interest Group. It used to be based out of Sun's offices, just around the corner from Monument. That was before Oracle, of course, acquired Sun. And it was fabulous. So a lot of focus on financial kind of applications and use cases because of the location, simply where it was. And I think at one time it was voted amongst the top 25 Java user groups in the world. But over time, things kind of, the guy who founded it went off to Spain, and things kind of, people went off and so on. But these days, it's been superseded by, I think, the London Java community, LJC. So that's fabulous, 5,000 plus members, and do regular events in central London and out in Docklands as well, where they've particularly focused on the financial community. Okay, so that's me. And one of the things that over the years, I had the great privilege to work for at Informix was this gentleman, Mike Stonebreaker. Some of you may or may not have heard of him. So, there's quite an old picture of him there. And so he won the ACM Turing Award a couple of years ago for his contributions to database technology. He's only the second database guy to do so. And so he's the guy who did Ingress, Postgres, Vertica, SciDB, Tamer, VaultDB, list goes on. He's got a fabulous model. So what he does, comes up with these wonderful research ideas, gets research students to work on the problem. They develop something, publish at prestigious conferences, subsequently develops a startup, gets funding, commercializes it, sells it, moves on to the next problem. That's a great model to have, and it's worked very successfully for him. But wonderful gentleman. I had, as I said, a great privilege to work for him for a while. He was the CTO at Informix, so very, very nice gentleman. Okay, so let's move on and have a look at this one. So I think what I can do, let me just switch back to this one, see which windows we got. So we can close this one. All right. Now, I read the requirements for this user group, and I think Luke sent it to my colleague, Tom, in terms of the structure of the presentation. And so I thought, well, best thing to do, let me keep the amount of slides down to a minimum, because I want to show you some demos and a little bit of code, which you as Java developers probably want to see far more than just slides. So I think I've trimmed this down to about 13 slides, of which I can talk a little bit, okay? And so that would hopefully allow enough time to give you some insights from my perspective, and then a chance to do some demos as well. So, have any of you heard of or used Ignite? Anyone? Okay, one person. Okay. So, I think this could be quite useful for you then. Many of you might be wondering, what is this technology? I've never heard of it. Well, possibly some competitors that you've heard of. Hazelcast, maybe? Oracle Coherence? Few technologies like that, sort of grid, in-memory data fabric. That's essentially what it is. So I'll do a little bit of an overview, okay, and then we'll cover a few key topics. So clustering, compute grid, data grid. There is kind of tremendous focus now on what is termed as a distributed SQL database. So Ignite has supported some SQL for a while, not very much, but and what they've done, they've considerably expanded that now. And also, there's additional capabilities that they're providing. So rather than doing everything in memory, now you can persist things. There's kind of durability has been added. Things can be written out to disk as well. And so they're gradually moving to this notion of a distributed SQL database. Quite a challenge, it's cluster computing and distributed systems, lots of issues to think about in terms of failures and delays and all sorts of associated issues. Little bit on machine learning, okay, worth touching on, I think. Maybe not quite as popular for Java developers. People tend to think of Python and R and MATLAB and these kind of tools. However, it could be useful. There are people out there, developers out there, using Java for machine learning. And then show you a few demos, and then we'll do some Q&A. Okay. So in terms of what is Ignite then, so it's very much, if you look at this kind of graphic on the right-hand side, there's a whole range of components around it. So originally started life as an in-memory data fabric. Basically, it's cluster computing. Right? You can build a cluster, just hook together a number of machines. I'll show you how to do this very simply in the demos. You just fire up a node. They auto-discover each other, and you can configure them, of course. But essentially what it is, it's trying to address two main problems, scalability and performance. And you can hook into existing systems, such as a relational database, Hadoop, or something like that. You'll be able to read data in, store it as a cache, and then be able to process that data really, really fast, okay? Because it's held in memory. You don't have to read from disk. Increasingly, the focus, as I said, in the recent developments is to add durability. So you'll notice there, possibly if your eyes are sharp enough and you can read the font there, so in the middle where it's got these 6 kind of disks, the orange part says in memory, and then the blue part says on disk. So there is a persistent store available now that allows you to store everything on disk and then cache a part of that in memory if you want to. So the durability, this is this whole notion of where this distributed SQL database is kind of coming in. More about that later. So compute, streaming, key value essentially this is what it does. Okay, so it's a key value store, allows you to write things and work with things, and again, the demos will show you that shortly. Increasing focus on improved SQL support, ACID transactions, okay, so this atomicity, consistency, isolation, durability from the database world, which we're all used to. If you're using the likes of Oracle or SQL Server or DB2 or something like that, then you know that these kind of capabilities are where the relational world has come from. Look at the NoSQL world, a little bit different today. So the likes of Mongo and Cassandra and other products use what we probably heard about, eventual consistency. So there's no guarantee that all of the data everywhere is going to be the same, but what you're willing to sacrifice is perhaps a small, a delay. It may be sort of 5 milliseconds, 10 milliseconds. It's all about guarantees. But you may be able to read the data, but it could be out of date, right? And there's, again, issues in terms of distributed systems design, which unfortunately physics, tells us we can't really solve. It's tough to do. So it's a memory-centric platform. Key value data grid, this is historically where it's come from, and we'll look at some put and get operations very shortly. But increasing focus, as I alluded to already, touched upon, distributed SQL database. ACID compliant, I think very important for some application domains, particularly in the financial world, where they're dealing with huge amounts of data and this kind of single source of truth. You need to be sure that things are as they should be, that the data is consistent, it's reliable, and so there are some challenges to that within a cluster computing environment. But high availability and horizontally scalable. Basically, just add as many nodes as you want to improve the amount of processing and improve the resources. And the whole idea is that you bring the processing to the data. Okay, so you're storing your data in this cluster, distributed across this various nodes, and you able to run your code on each of these in a certain way. And we'll again give you some examples of that. One of the nice kind of benefits. Awful lot of text here, I apologize, but the key kind of point here is that there is kind of dynamic class loading, and I'll show you an example of this in the demos. So what it is you as a developer, you've written some code, you can deploy that in your cluster, you can change that code subsequently, and then you don't have to worry about recompilation or pushing the code out. It's automatically managed for you by Ignite, right? And other key advantages that you can run this pretty much anywhere. I've got it running on a sort of virtual machine. I'll fire up a couple of nodes. They'll find each other. We can build a little cluster just for testing purposes. But the thing is that you could potentially run it in the cloud. You could run it, in-house. It could be in a hybrid. You could do it in a Docker container. Kubernetes, anything you want. There's a whole range of capabilities of where you can run it and how you can run it, and it's entirely configurable. Peer-to-peer cloud class loading technology. I'll give you an example of that. No nodes to restart, no jars to copy. It's automatically managed for you. Okay, so single biggest developer's productivity boost. Basically, as a developer, you just focus on what it is you want to write, the business problem, and the code to address that. And in terms of the deployment, leave that to Ignite. That will manage those issues for you. In terms of clustering, then, I've already mentioned this, so very, very easy to set up public, private clouds. Okay, it's sort of a whole range of environments that we've touched on previously. Excuse me, Amazon Web Services, Azure, OpenStack, and so on. Docker support. In the example that I'm going to show you a little bit later on, so there is this web console that I have, which is actually running inside a Docker container, but it can be used across the local network, which I've got running within the virtual machine as well. And it's also pluggable as well. There's a whole range of things and capabilities that you can add to it or customize depending on what your needs are. All right? So again, talk a little bit more about that later. Compute grid. Okay, so essentially what this is doing is that you have this notion of a job, and you can break that down into a number of tasks, and these can be sent off to various nodes in your cluster. All of this is sort of parallelized. They run return the result, you combine it, send it back to the client. And this fork join, you may have heard of it, or you can think of this as kind of map reduce on the kind of client side, if you like. That's another way to look at it. Some other kind of interesting capabilities and things. So checkpointing, okay, can be useful, especially you've got things like long-running jobs, and if things get really bad, parts of your cluster go down, or you lose the entire cluster, it's very easy to bring things back up again. And all of the standard features such as failover, load balancing, which you would expect within a cluster computing environment, that's all supported, okay? So it will look to see where the resources are being underutilized and be able to use those much better. And similarly, if some nodes go down, again, redistributing the jobs. There are notions of sort of primary and secondary and backup servers and things like that, okay? So it's managed for you quite well. One of the kind of developments recently within Ignite, as I said, is this notion of durable memory, all right? So historically, where it's come from is the in-memory stuff. And then the on-disk stuff is what's new. That's recent. So traditionally, what has happened is that because Ignite is based around Java, and a lot of it is the examples certainly that you can download from the Apache website in terms of the source and the binary distribution, they're all Java code. Okay. Other interfaces are supported as well, but that's what we'll look at today. The problem is that once you start dealing with large amounts of data, in the past it wasn't such an issue, but today, if you look, people are caching enormous amounts of data in memory, terabytes of data. We're talking about petabytes, and so this is very, very difficult to manage under Java. Garbage collection issues and the actual memory address space is a problem. So what Ignite does is that it uses this off-heap memory. Which potentially can be as much as you want or as much as you can afford. And this removes some of these problems and issues in terms of garbage collection. So Ignite manages that memory for you, does all the defragmentation, the GC pauses, all of those issues. And then the other thing is that particularly with the SQL, for example, you can conceivably have a distributed SQL database, you can do distributed joins. Because everything's cached, performance is going to be a lot faster. Those of you who've worked with relational systems, you know that the biggest kind of bottleneck, if you like, is doing joins. Those are the most costly operations. Now, if we've got things cached in memory, those things we don't have to worry about doing them on disk. It can perform those operations at memory speeds, and that gives us tremendous kind of performance in terms of getting results back much faster. So the on-disk stuff, it's optional, okay? You don't have to use it if you don't want to. You can enable it. It will give you the opportunity to write things out to disk. In some of the technologies that are supported, Flash, SSD, Intel 3D XPoint, and so on. There is a sort of a file system API as well that will allow you to write to pretty much anything. And there it says now store superset of data. So actually, that's not a good way to put it. So essentially, all of the data is stored to disk. Some of it is cached. Okay. The data that's cached, if it changes, it can be written to this write-ahead log. Again, if you're familiar with relational technology, this kind of terminology should be fairly known to you. And the thing is that helps in terms of performance. It also gives us kind of recovery mechanisms as well. And the other thing is that from time to time, as data changes in memory, these kind of dirty pages as they're referenced, and they're written out to disk eventually, that log can be shrunk and reduced. Another benefit is that restarts can be very, very fast because Ignite knows the state of things. If our cluster goes down for some reason, we can bring things up again very quickly in terms of recovering and bringing things back to a state. We talked a little bit about checkpoints previously as well. Those are important too. So the compute grid, the data grid, if you recall, I mentioned earlier on, these were the kind of the beginnings of where Ignite started from in terms of the memory and the approach that was used. So these are the more kind of mature components of this. Effectively, view it as a distributed key value store. Say the key and the value. And the value could be anything, not just simple types. Reliability, high availability, you can have replicas, automatic failover, we touched on that previously as well. So there is this ability, and again, if you've worked with systems like Cassandra or MongoDB, you know there is this ability to have backups, if you like, or you can replicate data across your cluster of servers. You know, depending on how much reliability you want, you can take single copies if you like, or you can back up all of the data if you have enough space. There's some issues and trade-offs related to that. All of that's possible. ACID transactions, again, there's a very strong focus on that because this is still very much a requirement today. So again, looking at this in terms of a variety of interfaces, so SQL, JCache from the Java world, if you use that and are familiar with that. And the on-heap memory, which we talked about, notice that it's much smaller and the off-heap is a lot larger, and that's all managed for you by Ignite. And again, historically and traditionally, where the focus has been in the past is being able to hook into existing data stores, whether it's a relational system, NoSQL, could be a HDFS file system, Hadoop, you know. There are connectors and integrators as well with some of these technologies too, to kind of speed them up. Transactions, so I'll give you a couple of examples of this a little bit later on, okay? So there's, the transaction support is quite strong, okay? So there's optimistic and pessimistic control, so you can take out locks, or you can do it in the sense that you're kind of hopeful that things aren't going to conflict. So in certain applications, if you think about computer-aided design, computer-aided manufacturing, for example, typically a designer will check out a part of the design that they're working on, copy it into their local workstation. Chances are that when they want to push that back out, it's not going to conflict with other changes. Other people are going to be working on other parts of the design. So in that sense, we are kind of optimistic. There aren't going to be any conflicts to worry about. Pessimistic, typically then in an ACID type of environment where we've got multiple transactions going on, we want to be sure that the system is consistent and those changes are reflected correctly. So, you know, if someone is putting £100 into my account and someone else is putting another £100, we want to ensure that both of those amounts get added correctly, that one of those is not lost, it's overwritten. So locking enables us to do that. And then we've got some fine-grained control in terms of read committed, repeatable read, serializable. Okay, so this gives us the opportunity of when we take the locks out. Do we take it at the time we just read something, or at the time we want to write it back out? And then serializability, again, very important, that if we've got multiple operations going on at the same time, it's as though we can do them as though they are done one after another. Again, we don't lose any updates or changes. And again, if you're familiar with JTA or JCA, all of that's integrated as well. Two-phase commit, this is fairly standard for a lot of distributed systems. So phase one, you're contacting all of the nodes, asking them, you know, get ready, get your locks. Everybody, you know, the primaries, the secondaries, all of the servers respond to that instruction if they're ready, and they'll reply back, yes, 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 yes. Once you've got everybody is ready, then you say commit, you know, apply those changes. One of the benefits of running an in-memory compute grid or data grid or a distributed SQL database is that if you're running it purely in memory, think about it, you don't have to worry about disk or changes written to a durable storage. There is nothing more complex than two-phase commit that you need. In some environments, you have to have something greater than two-phase commit. It's part of the problem of running a distributed system. And so with something like Ignite, and of course that applies to its competitors as well, two-phase commit is enough. There are some benefits as well in terms of simplifying that as well. So in some situations where, for example, we have just one primary server that stores the bulk of the data, and we have a backup, just one, then there's a sort of one-phase commit optimization that we can use as well, which again reduces the complexity, and that works quite well. So that will work only the situation where you've got a primary and one backup. Once we start to have multiple backup servers, storing additional copies of the data, we have to revert back to this two-phase commit protocol. Okay, so very well defined technology used extensively, and again has some advantages. So running purely in memory has some great advantages, but obviously adding durability and persistence and longevity, if you like, for the data, that if someone pulls the plug and my entire cluster goes down, then there's some other issues that we need to think about, and I touched on a few of those previously. All right, so the distributed SQL database then, it's as previously mentioned, both RAM and disk, okay, multiple language bindings, Java obviously, but .NET, C++, PHP, and of course, plug in your favorite business intelligence tool, Tableau or something else, to be able to do your dashboards and be able to do your charts and graphs and those kind of things. Again, using standard JDBC, ODBC. It's ANSI 99 compliant. Could be an issue for some people. I did a presentation in Amsterdam last month, and there was a lady who was asking, why have you gone for ANSI 99 and not 2003 or something else? Because there was certain capabilities that she was looking for, which are only available in later versions of SQL. And the thing is that if you know the history of SQL, that originally it started out as a language for managers to use, to be able to write reports. How many managers do you know who write SQL reports and are familiar with it? Not many, I guess. So originally the specification was quite small. Over time, as you know, it's grown and grown and grown as they've added more features and capabilities. I think today no single relational vendor implements all of it. It's just problematic. So they've enhanced it with things like objects and XML and all sorts of other capabilities. So ANSI 99 is a reasonable level. I mean, if you work with things like MySQL and Postgres and things like that, there's specific extensions to that, which will work fine. Asset compliance, again, all of the kind of sort of issues that we've talked about in terms of availability and scalability, on-premise and cloud, doesn't matter. You can use it in a range of different environments. And again, cross-platform, ODBC, JDBC, and so on. So very capable. All right. So a little bit on the machine learning. So the machine learning stuff is fairly new. At the moment, it's kind of just getting off the ground, if you like. So this is the kind of the high-level view, the vision, the architecture of what's planned. So I think the goal is to support the most popular machine learning languages that people are using today, which tend to be things like Python and R. But Java is obviously amongst those as well. And then you've got other things as well, such as MATLAB. Any MATLAB users? No, nobody? Okay, fabulous. I had the opportunity to take a course on MATLAB last year, and for matrices and those type of operations, I mean, it's absolutely brilliant. It's in the sense that how powerful SQL is, for example, or how powerful R is. One line or two lines of R code or SQL code, there's an enormous amount that it does. It's declarative. You're kind of trying to say, I want to do this. The system goes away and does all the hard work for you behind the scenes in terms of figuring out what's the best way to solve this query. And so MATLAB is great for matrix-type operations, which are very, very common and widely used in a lot of data science-type problems. So brilliant, you have a few lines of code, and it is very, very powerful. So that support is planned. Support for libraries as well. Now, you can kind of potentially see an issue there. So if these are libraries, how do we kind of run them in a distributed environment? A little bit difficult to do because they are black boxes. We can't look inside. We can't optimize them. So there is going to be library support available from Ignite. Okay, and there's a couple of examples in the code where you can see that. But equally, third-party library support will be available to the extent that you will be able to run it on a particular node, and distributed processing might be sort of an issue. Again, difficult to optimize if it's a black box. You can't see inside. There's no way to know what sort of things that you can do to improve that. Okay, so this is in the works. Okay, so keep your eyes on this. Could be very, very important. And as you know, today, of course, things like machine learning, data science, very popular topics. Not new stuff, as again, most of you know, a lot of these ideas, algorithms, principles have been around for a very long time. It's just the difficulty in running many of these types of problems, just not enough processing power. So the likes of Spark, for example, and technologies such as Ignite, the ability to cache data, parallelize operations, run things at memory speeds, iterative kind of problems as well. And we can do far more today and get these kind of business insights much faster than ever was possible in the past. So inevitably, you're going to see these type of sort of capabilities and support coming through. Okay, so let me switch to some demos then. Okay, so I've got a little bit of time. Luke very helpfully gave me the timer there so I can keep watch on what I'm saying. All right, now, one thing I apologize for is running this in VMware Fusion. The problem is I tend to break my laptop, okay? So I install and uninstall things, and then when you come to show a demo, it's Murphy's Law, anything that can go wrong does go wrong, things just blow up. So at least this way, I'm reasonably confident that things should work because it's an isolated environment. I haven't messed around with it, okay? So first thing to do, and you're probably squinting there or you need a telescope to see the font, so don't worry, I'll blow the screen up a bit there for you, okay? So we'll zoom in and let's have a look, okay? So I've got a couple of windows open. So in this one, okay, so I can see the blown up screen there, but it's not being reflected over there, Luke. Okay, that's a shame. That's a shame, okay. So let me see what we can do. All right, so I'll talk you through this, okay? So the first thing to do is let me just show you how we can so go to Apache Ignite, okay, download the binary distribution for your environment, okay, this is for Linux, you can get it for other environments as well, and once you've unpacked it, it's just a zip file, okay, all you need to do is just ensure that you've got a suitable version of Java installed. I recommend Java 8 if you can, okay, that's the best one. And that's it. That's all you need, all right? And then it's as simple as just firing that up. And if you look in the top right-hand corner there, all I've done is just gone into the bin directory. I've fired up a node at the moment. And again, just draw your attention here. So I know it's a bit small today. So it says servers equals 1. It's one node. Not much of a cluster at the moment. Okay, so I think this is little snitch. So just allow that. Okay, so another window. Let me do the same thing there again. All right, so just firing up another Ignite node. What will happen is the two will auto-discover each other. And if we look down at the bottom here, again, we can see here, it says servers equals 2. And in the windows at the top there, if I just switch to this, there we go, servers equals 2. So they're running on the same subnet, okay? And these nodes have found each other, they formed a cluster, okay? So now we've got a cluster of 2 machines, if you like. It's a virtual environment. I could add more if I want, potentially, until I've exhausted the amount of memory that I've got. But you can see that even with this environment, it's fairly easy to do that. All I need is Java 8, just download, unpack, and I can start using it within 5 minutes. Okay, I mean, it's as simple as that. The other thing that I need to run here, there's a web agent that I need to run in order to be able to show you the web page, okay, which let me just fire that off, okay, otherwise things are not going to work. And this thing here, what this is there is a web console, okay, so it's a kind of a nice graphical tool, which I'll show you in just a moment, which kind of allows you to see some metrics on your local cluster. And generally, the way that you would use it, go to console.gridgain.com, register there just to play around with it if you like, have a go. Typically, though, you won't run it from GridGain's website. I mean, you will have your IT people install a local version. You will have that running internally within your own private network. And one way that you can, again, just play around with it to test it is that within a Docker container, which is what I've done here, I've downloaded it. I've got web console we're running within Docker. It's a private install. I don't need to go outside. And that's just a way for me to be able to play around with it. So in actual fact, when I've done that, you'll get something like this, okay? So this gives you the opportunity to do a number of things, so you can have a look at what clusters are running. At the moment, it's found one, okay, just over there. Okay, and I need to be careful because Luke told me I need to stay within the field of vision for the camera. And we can have a look here. So it's picked up the fact that there's a couple of nodes running within the local environment, and I could have a look at that, do some monitoring, okay? Dashboard, okay? So let's just have a look at that. All right, so it just takes a moment or two to refresh this. This machine itself has only got 8 gig, of which I've given 4 to VMware and then 4 for Mac OS. So it's enough, I think, just to demo a few things. So you get some statistics, you get some heap size, CPU usage, a few other useful kind of metrics like this. And it gives you some information here about what other nodes that are currently found, or where they're running within the same environment, so that the IP address is the same, but these, each node had its own ID, which is given over here. For example, what's the CPU load, and so on. Okay, so there's not much to show here because I'm not actually running very much. As you can see, all I've done is simply fire them up. But one of the options that's available at the top here, if you look here, there's a blue button there, it says Start Demo. So that gives you the ability to do a few things from this environment, which will enable you to try out a few things. For example, let me just close this. Okay, we don't need to do that. It's running already. Okay, and it will refresh. It kind of gives you this sense that you're running against a particular cluster. Okay, and let me just select queries over here, which is along the top. Okay, again, apologies, it's slightly slow. Okay, just there we are. And you can, from this environment, okay, just give that a moment to refresh. Okay, so apologies, I'd love to zoom in and show you this, but it's not going to be reflected on this side. But here you can type in SQL if you want, dynamic SQL, be able to query and run it from within this environment. And there's various caches that you can talk to. So think of a cache as a little bit like a relational table, all right? It's something that you create. You do put and get operations in that. You can run queries against it, okay? And then you can destroy that cache if you want. And you can have as many caches as you want for different purposes. You could have one running for streaming applications. You could be doing an SQL job in another one. It just depends on what resources that you have available, okay? Okay, so we're nearly out of time. And what I will do here, so just to quickly show you this, okay? So as part of the distribution that you download from the Apache Ignite website, there is a whole series of demos. Okay, so there's a pom.xml file. You just load these into your IDE. All of this source, these examples are in Java. Okay, so there's a whole range of different types of code examples, something to show you how to do work with a compute grid, examples with the data grid, okay, so the put and get operations within a cache. There are SQL examples as well, some machine learning capabilities which you have to enable, okay, so the machine learning is something that it's a checkbox at the time that you're loading in the project that you say, I want to use this, okay. So there's a lot, and again, you can have a look at all of this Java code. It's all on GitHub as well if you want to just peek around rather than having to download this and load it into an IDE. You know, if you're a skilled Java developer, you can just go away, have a look at the code, and it'll give you a good sense of what's going on. Transactions, okay, so all of these things to support it. Okay, so I'm out of time, and I think that's pretty much what I wanted to show you. So the demos are dead easy to run, as I said, just load it in. All of this is Java. You guys, you're proficient Java developers, I'm sure. You'll have no trouble understanding this stuff. All standard code and very easy to run and to build. I stopped using Java a long time ago because I went on to do other things. And then when I started looking at this stuff again, I mean, I need a little bit of time to refresh myself, but I found it surprisingly, everything works, you know. It all builds, it all runs, it does what it says on the tin, you know. If it says it's going to run these operations, it's going to do some transactions, or it's going to do put and get operations, it works, okay? That's the great thing there. Okay, so just before Q&A, let me just point out a couple of things. So that's me, a younger me with hair. So this is on the Big Community website, okay? So that's bigcommunity.net, which is actually managed, it's in Southeast Asia, okay? So I had the opportunity to work with MDEC from Malaysia. It's one of these kind of government boards that they're launching some initiatives to do with big data and analytics and data science. They very kindly gave me some space on their website. So there's a kind of a 6-part series that I wrote for GridGain, which is there. All 6 parts are there, just kind of basic introduction for beginners on each of the major sort of components. So I talk about streaming, I talk about clustering, I talk about data grid, a little bit about SQL. The next part is on machine learning, which will be written up there in a couple of days' time. So if this is something you're interested in, just get involved as a beginner. That might be a good place to start, okay? The other thing is that if you want to reach out, I'm on LinkedIn. Feel free to connect. Okay, and my email address is just my first name dot last name, akmal.chaudhri@gridgain.com. Okay, so if there's anything that you want to follow up on or you want to ask or it's not clear. The slides I will send to Luke, okay, and again, links to the demos, other resources that I think would be useful if you're interested in starting out on this. Again, I will send this all to him within the next day or so, so all of that will be available. Great,